because you want to onboard developers quickly, you want them to become productive quickly, and you don't want to have them spending time figuring out, learning the intricate details of how your Helm charts work in your particular way, in your particular Kubernetes cluster.
Today, I'm joined by Chris Stephenson, who is the CTO at a company called Humanitec, and it's a software tool/platform for helping engineering teams build out their own internal development platforms, which is actually going to be the main focus of today's discussion. So I'm super excited to have Chris here. And Chris, before we dive in, could you tell the audience a little bit about yourself so that they know and can have context on where you're coming from?
Yeah, happy to be here. So my name is Chris. As Sid's already mentioned, I'm the CTO here at Humanitec. And I've been in this software industry for a long time and spent a lot of that time working in the area that we would call, I guess, internal development platforms, from kind of financial services through to big tech companies, now through to Humanitec. So this is an area I'm really passionate about, and I'm really excited about what we're doing at Humanitec for internal development platforms.
Great. And so before we actually dive in, I think that terminology, internal development platform, I'd never heard of it until fairly recently, but the concept has been around for quite some time. Can you maybe just start off by defining what you would call an internal development platform?
Sure. So an internal development platform is effectively the tooling and productization, I guess, of the developer experience. So at a large company, what you tend to find is that people are repeating a lot of things a lot of times. So you have developers who are obviously writing their software, and then you have operations teams who are setting up infrastructure for those software developers. And between them, they get an application built and running on some infrastructure. As you get to larger and larger companies, you start noticing that a lot of people are doing the same thing all the time. And so you tend to build some kind of platform to help them. So famously, Google, for example, created an internal development platform, which has now spawned out into the likes of Kubernetes. So they built Borg and a whole load of internal tooling that allows their developers to just focus on writing the code for their applications, and then let the platform work out how to deploy it and actually run it at scale. And you see this pattern repeated in lots and lots of companies. So an internal development platform allows the developers to self-serve the tech and tools they need in order to get the applications running. And at the same time, it allows the operations team or the platform team or whatever you want to call them in your organizations, the ability to manage and make sure that that the infrastructure and the tech and tools that the developers need are served and ready for them to be used. So you can think about an internal development platform as being a bridge between the developers and the platform teams, such that developers can do their job without being blocked by the operations team or so on. And the operations team can ensure standards are applied and that things are scalable, and they have nice things like backups and security policies and so on, without having to lumber all of that on top of the developer's shoulders.
That makes a lot of sense. And I think the term IDP, or internal development platform, is kind of an umbrella term that can capture a lot of different things. And at some companies, it might be a fairly lightweight set of scripts and tooling that help developers to streamline their own operation and deployment of their software. At other places, it might be an attempt to recreate a full platform as a service experience for that team. And so I think it's important to understand that a lot of things fall under that category, and for different size organizations or different maturity of engineering organizations, where you fall along that spectrum is going to depend a lot, right? And what's right for one company might not be right for another, given the different scales and current engineering challenges that you're facing.
That's absolutely true. And I think one of the other things to think about is kind of over time, what an internal platform means has changed as well. So not only do big companies have big company problems and small companies have small company problems, but also if we go kind of back in time and we look at, say, the problems that existed in a company 15 years ago, they probably weren't in the cloud, everything was running on premise. The developers still had the problem that they needed some infrastructure to run their code on, but that infrastructure was maybe VMs. Maybe you have VMware running in your data center and you're provisioning VMs for an application. Today, you're maybe talking about deploying containers into something like Kubernetes in a cloud environment. So like what an internal development platform means has also evolved over time. And as you say, a large company, you might have thousands of developers all building small parts of a very big application, maybe a large microservice application. That has very different challenges to maybe a startup which has an engineering team of 5 to 10 people, where everyone is kind of looking after everything and people have a lot more visibility and understanding about how the whole system fits together. So an internal development platform isn't a one-size-fits-all thing, as you say. It is a particular thing that works for a particular size of company at a particular point in their time. And the internal development platform should evolve as the company grows, and it should also evolve as technology changes.
Yeah, I agree with that 100%. And I think at what point do you start to see companies go down the path of building out something like an internal development platform? Does it make sense at an early stage startup where you just have a handful of engineers, or is it something that generally gets started a little later on in an organization's journey?
So I think that's a very interesting question. I think there's a few things to kind of consider first. One way of thinking about an internal development platform is to compare it to a platform as a service. So probably the most famous one of those is Heroku. And a lot of companies got started by building on Heroku, which provides a lot of the functionality that a company needs for getting their initial versions of software out the door. And many companies successfully scale Heroku and continue using Heroku as they get bigger and bigger. But what you tend to see is that as companies get larger, or their product becomes more complicated, or they start needing different technologies, that they kind of outgrow Heroku. So that's kind of one area that we see. So if you are able to use tooling that already exists and solves a lot of these problems, you can outsource your entire internal development platform to a third party and use a platform as a service. Where we tend to see people coming in to figure out how they build their own internal development platform is when they've migrated off or kind of outgrown these kind of platforms as a service. So maybe they need some specific scalability, maybe they need integrations with certain technologies, maybe they just need a bit more control. And at that point they say, okay, let's, for example, move to Kubernetes. And that's great, but then you have to bring all of these developers who are used to the really easy and nice development experience that you have with something like Heroku. And then you are saying, well, actually now you need to learn Helm, you need to learn all of this tooling, you need to throw manifests in, you have to understand what a replica set is, you have to understand how we manage namespaces and all that kind of thing. And at that point, you may find that building an internal developer platform to abstract away and better manage the underlying infrastructure you have might make sense. The other thing you also see is as companies get bigger, maybe you started off on Kubernetes and everyone understood everything. All the people who joined got stuck in. They all understand how the Helm charts work. They all understand how your CI/CD pipelines work. But as your company grows, maybe you get from 10 to 20 to 50 to 100 developers. By the time you're employing developer 101, this person probably doesn't have the ability to understand everything that's going on, and they end up kind of lost in a big sea of complexity. And at that point, again, it makes sense to bring in an internal development platform because you want to onboard developers quickly, you want them to become productive quickly, and you don't want to have them spending time figuring out, learning the intricate details of how your Helm charts work in your particular way, in your particular Kubernetes cluster. You want them just to say, focus on the code they're writing, and someone else or rather some other system should be taking care of the details of how does this code actually get to run and how do we manage configuration across environments.
Yeah, that aligns with my advice that I often give to the early stage startups that I work with around use a platform as a service if you can until you outgrow it, either from you no longer fit in the box that they provide you and like the specific type of workloads that they are specialized in, or you're starting to see the premium price that they're charging you on top of the raw resources really hit your wallet. In terms of the core elements that make up an internal development platform, what are the different pieces that you see as being really important as you as an organization are thinking about going down this path of building out an IDP?
So I think one of the things to do is actually to take a step back. So we often see people come in and say, hey, we've heard of this thing called internal web platform, we want one for our organization, which is great. But the thing to do there is to take a step back and say, not work out, can we build an internal web platform, but find out what problems your organization actually has. And I think this is something that people often forget in the excitement of wanting to get started building their internal development platform. What you're doing is you're building an internal product, which means you need to think of it like you're building any other kind of product, be it consumer product or B2B product. You have users, you have customers effectively, and you need to work out what problems they have. So you need to talk to your developers and find out how can you improve their developer experience? What are their problems that you're trying to solve? You need to talk to your operations team. What are the challenges they're experiencing? How are they, what would they like to see? What do they not want to see? You've got to talk also to your engineering management. You've got to say, how do you think the internal development platform will help drive productivity or quality or whatever metrics are important through your organization? So the most important thing about an internal development platform is it needs to solve the problem of your organization. Now, having said that, there are some like broad themes which always come up. And I think the main thing that comes up is developer self-service. So this is the key thing that an internal development platform enables. Now, how that self-service works depends on your conversations with the developers. But broadly, developers want to be able to get their code running with the minimal amount of dependencies on other people. So if I can set up my code and I can get connecting to a database and I can get it exposed through DNS without having to go and send a Slack message to the DBAs to ask for a database, and without having to go and file a ticket with the network team to give me a DNS name and all of that kind of thing, I'm going to be a happy developer and I'm going to be able to be more productive. So one of the big themes we see in the internal development platform is this self-service. And on the other side, you've got the flip side of that, is that one way of doing self-service is to give everyone access to everything. But what you then see is a slow descent into chaos. So if every developer is setting up their Postgres databases however they want, you're going to have like 150 flavors of a Postgres database, all configured in different ways, different security policies on different networks, with different levels of resilience. And that's going to become a difficult thing to maintain and manage going forward. So the other sort of flip side of the developer self-service is providing some structure and a way for the operations team and the platform teams to think about how to provide those sort of self-service resources in a way that works for developers, but still conforms to security policies, best practices, and other elements that come into provisioning infrastructure and things like networking and security and all of those best practices.
Yeah, I think one thing that you mentioned that I'll call out specifically, and I've heard a lot of people talk about in this space, is treating it not just as a platform, but also as a product, and really understanding that you can't develop any product in a vacuum away from the users. And so it would be a huge mistake to go off and build this massive, intricate, amazing system without getting it in the hands of users and understanding what problems you're actually solving. And so I think that's a key thing that teams and people who are in the space need to consider as they're planning and executing on anything to go with an internal development platform. I know that Humanitec and your organization has done some benchmarking studies to try and understand DevOps maturity and Kubernetes maturity across the industries. Are there any takeaways from that you can share with the audience that are relevant here as you think about, hey, how mature is your organization from a DevOps perspective, and what does that mean for whether or not they should be implementing an IDP, what types of things they should be considering as they roll that out?
Yeah, so I think looking at our kind of research there and kind of comparing it to the wider piece, I think everything is pointing in the kind of same direction as what you see for example, state of the DevOps report and so on, is that there is a large spectrum of teams with different levels of maturity. And there are some kind of clear best practices that emerge across the industry where you see like the higher performing teams are kind of adopting those best practices. But if we look specifically at the kind of DevOps maturity and so on, one of the things we see is time taken to perform kind of basic actions. So these things we talked about provisioning your infrastructure, how self-service things are, we see that there's quite a range of kind of times or effort that's exposed for people in order to try and get to various things. So like, how long does it take you to spin up a new environment? How long does it take you to deploy a workload? And then the kind of flip side of that, how often do you need to do that? How often do you need to make a change to configuration? These sort of things, it turns out, can be quite expensive actually in an organization. And these are kind of signals that maybe it's worth putting in some kind of structure, some kind of developer platform to speed these things up or reduce the load on the developers, either the cognitive load, like the complexity of just doing stuff, or just standardization so that you can get more achieved with less variation in the output that you're achieving. So whether that's from the policy perspective or whether that's just our infrastructure kind of looks the same across all of our projects, and people can switch teams easily and understand what's going on without having to kind of relearn a whole stack from the ground up.
Yeah, and I think those costs actually compound. A previous guest on this series, Charity Majors, has talked about this, but you need to be deploying rapidly, because if you push a change and it doesn't make it out to production until 3 hours later, by then you've already gone off and done something else and you've lost the context. And so if something does go wrong, it's going to be much harder to debug. So not only are you spending more time babysitting your pipelines and making sure that things are working and checking if the error rates have gone up, if you don't have automated tests for that, but also the eventual fix, if there is a problem, is going to be much more difficult. So I think it's important to, as you mentioned, sort of understand how mature those portions of your systems are and work to improve them over time.
Yeah, and I think that compounding effect is very real. And I mean, it's often also tied together with this concept that we just mentioned as well, very briefly, of kind of cognitive load, is that the more complexity you as a developer have to deal with in order to get something done, then the slower it's going to be, the more context switching you need to do, and fundamentally, the more mistakes you're likely to make before you actually achieve what you want. And having this kind of requirement to context switch back because it took 3 hours to get into the next environment is another form of cognitive load. You still have that thing sitting in the back of your head. You can't concentrate on your next task because you're mentally checking in about whether the thing you did before is actually finished or not.
Yeah. And you touched on earlier the concept of IDPs evolving over history and how it's changed over the last 20 years, as well as how a platform within a company will be a constantly evolving system that matures alongside an engineering organization. Let's look at that a little bit and talk about how these types of systems evolve. Does it make sense for a company to sort of build these incrementally versus do you need to have some threshold of maturity or some minimum viable product before you can release it? And what do IDPs look like within teams of different sizes?
Based on this fact that an IDP is kind of what your company needs at this point in time to achieve what you need, I don't think there is a minimal, I mean, there's always a minimal viable product for a particular scenario, but I don't think we can talk in general about that being a minimal viable product. So for example, maybe someone's first iteration in the company of an IDP is just some standardized Helm charts for deploying into Kubernetes. I mean, that's step one. Maybe there are some scripts which do some linting, and then you maybe set up some kind of GitOps workflow. All of those are kind of steps towards some kind of internal development platform. Now, the interface here is editing some values files in a Helm chart and committing into Git, but there's a process there and a kind of standardization starting. Now, as you grow out, I think you're going to, sort of increases sophistication. You're going to try and reduce the amount of duplicate work or the amount of confusing work that people need to do, and it'll grow from there. So I think it's entirely possible, and this is actually what we see when we talk to companies, that internal development platforms kind of evolve from someone solving a particular problem, and then things get joined together. The problem is that that kind of undirected growth tends to lead increasingly to a mess of like scripts that are all poorly maintained and like joined together by a kind of duct tape and string and stuff like that, and very quickly they become more of a problem than what they're originally solving, or rather they become really brittle. So that means that when a new technology comes along, or maybe a new application architecture is introduced, that brittle structure no longer allows you to use this. And so either you end up building a parallel system, or you try and shoehorn things together and then things start becoming really flaky. So that is the kind of natural, kind of undirected flow of an internal development platform. I think it's still an internal development platform, it's just not a very good one, because it's kind of just evolved over time. This is where bringing in that product mindset and looking at it from a directed perspective and saying, well, this is what we want to do now. We want to achieve these best practices. We're not just tactically solving the problem of today, but we're trying to foresee where we're going to be moving in the future. And unfortunately, that requires a lot of investment. It requires people to actually have a dedicated platform engineering team that can manage this, dedicated product expertise in that platform engineering team who can manage that kind of future growth and are talking to other stakeholders in the business. Hey, what is your next project? I heard that you're interested in using technology X, or I've heard that you are trying out a new application architecture. Let's talk about it. Let's see whether the platform team can support you in achieving those goals, or at least learn from you so that we can support other teams that want to do the same thing later. So that kind of forward-looking piece is really how you keep that evolution happening within an organization. The risk is that someone solves one problem and they solve another problem and they just kind of pile up, and eventually you have a kind of big soggy mess of generally bash scripts, which no one really likes to dig into and figure out how they work.
Yeah, I think even just a quick pass at setting the eventual goal as a North Star, such that when you are solving today's problem of, oh, this is on fire, it needs to be fixed, how do I do that? Having some official documentation saying here's where we're trying to get to with these systems will help inform the decisions that any individual is making of whether something they're doing now is going to have to be ripped out entirely, or whether there is a path for it to sort of fit into that eventual vision. And so that's, I think, something that I've tried to use in the past. It's like setting a goal for where you're trying to get to, such that you can use that as a guiding principle, or assess any individual decision against that. And that's helped tremendously in the teams that I've worked with on that front.
Well, definitely. Yeah, having a vision is like a kind of 101 of getting a product out the door, is know what you're trying to achieve, like what your eventual goal is.
For sure. And these days it seems like Kubernetes has become sort of the de facto standard for companies building platforms like this. I've talked with individuals at companies who are not using Kubernetes, and so I know it's not the only option. What different approaches and sort of foundational technologies are you seeing across the industry in the work that you do?
So I think Kubernetes is a really great technology for building an internal platform on, and part of the reason is the kind of design choices that Kubernetes made early on, like for example being fully declarative as a concept. This works very nicely with techniques such as GitOps, or just in terms of kind of ending up with a robust way of defining outcomes rather than defining steps to get the outcomes. And these all kind of make it much easier to build a platform on top of things, because at the end of the day, the platform is about getting your output, so getting your code running somewhere with a certain number of requirements or dependencies satisfied. And so what we see a lot of is that people are building additional layers using Kubernetes as a kind of base platform in order to expand these things out. So be that using Kubernetes to define infrastructure, using something like Crossplane, or whether we see people who are using a kind of pure GitOps approach to ensure that everything is reproducible and it's easy to roll back configuration changes to a known state. All of these things kind of come out of this kind of declarative approach. But then there's no need to use Kubernetes. You have other tools. So Terraform is, again, another example of a kind of declarative way of defining infrastructure. And we see that being a core part of many people's internal development platforms. And so if you're not running on Kubernetes, but you're provisioning EC2 instances, then having some kind of base set up using something like Terraform in a well-structured way, using some of these kind of maybe GitOpsy type principles. There's a big debate about whether using Terraform with Git can be GitOps or not, but like using these kind of principles can really help solve some of these problems that companies that are not using Kubernetes are facing. But the kind of fundamentals, the kind of modern thinking, or like how people are thinking about platforms, is very much this kind of declarative approach, and the Kubernetes is a good model for that. Although Kubernetes is obviously not required to build your own internal development platform if you're not using Kubernetes.
Definitely. And I know Humanitec recently hosted a conference all about platform engineering and internal development platforms called PlatformCon. That was just a few weeks ago. Are there any takeaways from that you'd like to share in the context of this discussion? I'm sure there were a number of great presentations highlighting work in this space across the industry, or many industries. So interested to hear if there were any particular talks or trends that you saw that you'd like to share.
So first thing is the PlatformCon, we were entirely blown away by the amount of interest. We had close to, I think, 7,000 registrations, and we had over 70 separate talks were submitted as part of this. So like the platform engineering community is clearly big, and it is clearly wants to kind of talk and communicate and discuss ideas. So I think that the biggest takeaway is that platform engineering is a discipline, that there are thousands of people around the world who consider themselves platform engineers and are in the space of improving developer experience, building their own internal development platforms in their various companies. But I think in terms of like kind of some of the key things that came out, the track that I found particularly interesting actually was the so-called culture track. So this is not looking at technology or looking at kind of success stories of internal development platforms within organizations, but really talking about how you can introduce an internal development platform to an organization. And there were some great talks. I think one particular that stood out to me was one by a chap called Galo Navarro, and he was talking about how do you sell an internal developer platform into an organization, and that you have to tell a different story to the executive team, to the engineering managers, to the operations team, and to the developers, and really highlighted this kind of platform as a product approach, but from the perspective of an engineer who was trying to build a platform and needed to figure this out for themselves. So that was kind of one of the particularly interesting things. That how does organizational change impact internal development platform, and how does internal development platform drive that organizational change that we want to see within these engineering organizations?
Yeah, that's great. And I'll put a link in the description to, I believe there's a separate YouTube channel that has all those talks hosted. Is that right? Yeah, so I'll link to that.
So yeah, all of the talks are now on YouTube, and I would highly recommend people to go and have a browse and have a watch of some of those talks.
Awesome. And so I think that kind of gives the audience a pretty good foundation of what internal development platforms are, how they should be thinking about them in terms of their own engineering organizations. Let's shift gears a little bit and talk about your company, Humanitec, and try to understand where you fit into this space and how you help engineering organizations to advance along their own IDP kind of journeys. So what is Humanitec?
Right, so Humanitec is what we describe as a platform orchestrator. So it's not an internal development platform in its own right. It is something you can put in and build your internal developer platform around. And what we've tried to do is kind of look across now hundreds and hundreds of companies and see what kind of challenges they faced from a DevOps perspective, from a developer experience perspective, and try and distill them together in the context of cloud technology. So as I mentioned, internal development platforms have been changing as technology's changed. We've recently come to a position where, as you mentioned, most companies are standardizing on Kubernetes. Most companies are standardizing on the standard offerings of the large cloud platforms. So you have an opportunity to actually create something which has broader appeal, and we don't have to support, I don't know, VMware over here or a particular hardware vendor over here. We have some degree of standardization just across the industry in general. So with Humanitec, what we're doing is we're focusing on Kubernetes-based platforms, and we're very interested in helping people deal with tricky things like configuration management. So one of the challenges we constantly hear from people is, how do I manage my configuration when I need to promote things across environments? It's really easy to promote an image from dev to staging to production. That's relatively straightforward. But what happens if I also need to make some configuration change? I need to add an environmental variable, or I introduce a new dependency on, I don't know, a Redis cache. How does that dependency follow my code through as we promote through these environments? And that's one of those areas of kind of cognitive load we see on developers, where they are today having to pull up the Helm chart from dev, pull up the Helm chart from staging, and then check line by line, okay, should this change or should this be the same? Do I need to copy this thing across? Do I not need to copy this thing across? That's very tiring, also error prone, and it's kind of a difficult thing to think about. So one of the things we do with Humanitec is we have this concept of dynamic configuration. So when you want to build your configuration as a developer, you want to deploy something, you set your expectations or your dependencies or requirements for your workload up front, and then the platform team have defined how these requirements are satisfied in different environments. So maybe in dev, you all point at one large RDS instance for all of your Postgres needs, whereas in production, you have carefully curated and managed Postgres instances run by your DBA team. But from a developer's perspective, you just say, hey, I need a Postgres. Can you just make sure there's one for me? You give that all to Humanitec. Humanitec goes, great. This is kind of what we know. We've pulled in some definitions from the platform team, and we can generate you some configuration, which then gets pushed into Kubernetes, and your workload runs. So it's really about orchestrating things together. We're not choosing what Kubernetes distribution you're running. We're not telling you which database provider to use. We're not even telling you what cloud to use. All of that is a free choice for the developers and the platform team to figure out. But what we're doing is orchestrating these things together so that you as a developer can define something once and then get it moving through your environments. And as a platform team, you can define what it means to satisfy dependency, to provision some infrastructure, or what kind of best practices are for instrumentation, APM, security within your cluster.
The platform team who's authoring those guidelines or regulations, is there a domain-specific language that Humanitec has created? Are you using some existing language that's out there? How are we actually authoring those types of things?
So, I mean, it's probably much simpler than it appears when I explain it here. So, what the platform team will mainly spend their time in is dealing with so-called resource definitions, which are effectively just descriptions of how to provision something. So, for example, this dev database in RDS, you know that it's going to be in this AWS project, so you define the AWS project. You know it's going to be this particular RDS instance, so you define the RDS instance, and then you say, I would like to generate a blank database, and I want to generate a username and password for it, and then I want to pass these things back. So we just have a series of, they're basically YAML files, which just define these input parameters. There's a type of the resource, so that would be a Postgres resource. And then we also have it linked to a driver, which is the thing that actually does the mechanical work of provisioning the thing. So we provide a load of drivers out the box, but there's also, you can use Terraform to act as your driver. You can write your own drivers if you want to do something super funky. So as I said, it's more of an orchestrator. The actual details of how you do that provisioning and what it means for your particular company is again open to the platform team to define. So we provide some structure around it in the form of these YAML files that you can fill out, but the actual details of how that work is entirely up to the platform team themselves.
Yeah, it sounds like one of the big value adds is this sort of well thought out and battle tested structure for how to organize the different pieces of an IDP. Like, you're not prescribing the underlying technology or the implementation details, but instead you're saying here's a set of things that you ought to have thought about and defined based on the experiences of hundreds of different organizations who have gone through this in the past. Is that a fair assessment?
Yeah, I think that is great. I mean, we usually simplify it down to a developer say, hey, I need a thing. And the platform team say, this is how you create the thing. And that's basically what's going on. Like, developers say, my workload needs a DNS name. And the platform team say, yeah, sure, if you want a DNS name, we use Route 53 to set it up. Here you go. And at a kind of fundamental level, that's all that's really happening inside the orchestration, the platform orchestrator inside Humanitec. But that solves a whole load of these problems that we see commonly reoccurring. So the self-service problem for developers, the ability to standardize on the platform engineering side. So these things which are common themes which come up again and again. And the trick that we're trying to play here is to find the correct level of abstraction so that you can satisfy the self-service needs of the developers and the control needs of the platform team without having for them to jump out or escape from the abstractions that we've designed. So as you said, it's a way of structuring rather than a kind of a big, heavy system that is churning a load of wheels.
Got it. And if you could talk for a minute about the different types of customers and industries that you see using Humanitec, and maybe any case studies of how they're using it would be, I think, really informative. So
one of the really interesting things here is that we don't really have a particular industry. Like, we're used across industries. So as you were just chatting to someone earlier today, in that we have people in HR tech, we have financial service companies, we have large technology companies, we have companies that do data privacy stuff. So like, we have a whole range of companies. The only kind of common thing is that they're all building software that runs in the cloud. So I think that's really interesting, is that there's no particular vertical. It turns out that the problems that, say, an automotive company has is similar to the problems that an HR tech company has, is similar to the problems that, data privacy people have. Like, fundamentally, everyone is trying to improve the developer experience, allow developers to self-serve while still managing the kind of complexity and the process and the standardization around things like infrastructure and application configuration. So I think that is super interesting. What we do see is that the companies that are most interested tend to be on the larger side. So usually we say 50 to 100 engineers plus is when you start really getting a benefit from the platform. We have a couple of companies that are much smaller who are customers of ours, but they tend to have very kind of specific needs. So they were trying to scale up, for example, very, very fast, and we're trying to kind of use Humanitec as a bit of a PaaS rather than as an IDP itself. Or maybe companies who are initially had grander visions and have now kind of scaled them down. So that tends to be on the small side. But really, when you get to the larger companies, we talk hundreds of engineers, potentially to the thousands of engineers, that is where you get this benefit, because a lot of the things that we talked about at the start, a lot of the problems that people have are more big company problems. So doing self-service for 2,500 developers is a very different proposition from 25 developers. Just in terms of like what you need to know, the amount of policies you'll have, the amount of security people that you'll have getting involved in how infrastructure is set up and how applications are architected. So generally, the larger companies tend to have more of the problems that Humanitec can help with and come in and structure their processes so that their developers become more efficient and their platform teams and operations teams become a little less stressed.
Awesome. Yeah. And if people want to learn more about IDPs, internal development platforms, and or Humanitec, where should they go?
Yeah, so there is obviously Humanitec.com is a great place to learn about Humanitec. We have also a series of webinars, which we have speakers usually every week coming in from all over the place to come and give us their experiences of either building internal development platforms or particular things in kind of platform engineering and platform engineering adjacent topics. So that's definitely a place to go. There's also a community site, internaldevelopmentplatform.org, which has a load of people who are in the internal development platform space. You can find profiles, you can find case studies and things in there. And then there's also a platform engineering Slack organization, which which is, I guess, where the seed from PlatformCon came from, which if people are into platform engineering, they should definitely go and join that Slack organization. There's a lot of interesting chats going on all the time, and people are kind of exchanging ideas, and it's a really vibrant community.
Amazing. I'll put links for all that in the description so people can easily find them. And thank you so much, Chris, for your time today. I really enjoyed the discussion. I think the audience will as well.
Thank you very much for inviting me. I've had a great time.
All right. Take care. Bye.